Hey guys, and welcome to this new class in flight instruments. In this case we will be studying the second part of the gyroscopic instruments. We will go further into detail on the three main instruments which work based on the gyroscopic effect. Okay, so first of all, as gyroscopic instruments we have the attitude indicator. This is probably the most known instrument that you can quickly identify in almost all types of aircraft. Okay, this first version is the very basic idea of what the attitude indicator should aim at. Okay, and here we have an electronic device which is the same, but at the same time you can see that we also have information about the speed and the vertical speed over here. Okay, so again, in civil aircraft, usually we will see something like this. In commercial aircraft, we might see various types of electronic devices, electronic instruments, all in one. Okay, as you can see over here. Right, so just quickly go through it. As you can see, it's simply this divisive white line over here, which divides what would be seen as this would be the horizontal axis. Okay, with Earth indicated as brown on the part from below and blue indicating the sky upwards. Okay, so this is the main difference. It's pretty clear, and as you can see, the 10 and 20 indicate the degrees at which we are the pitch of the aircraft with respect to the horizontal axis. Okay, now this instrument can identify the roll axis and also the pitch axis. This is the idea. What else? This is the electronic, as we said, and if we look a bit more into detail to what this attitude indicator looks like, as we discussed before, these are gyroscopic instruments, so are based on gyroscopes, basically. Okay, so a friend of mine works at the airport, and he's doing usually maintenance on different types of aircraft, especially civil aircraft, which mean are little aircraft with very simple instruments, okay, or the most basic instruments. So this is an instrument that he gave me once, and as you can see, it's pretty clear that this looks like a gyroscope, okay, with the gimbal or the external ring, okay, and the rotor, which would be moving over here. And this phase over here is simply what you see over here. Okay, this is a quick video that I made to visualize how it works. Okay, so as you can see, by moving the gimbal in this way, all of the axes orientate, and it's just a way of visualizing them mechanically. It makes sense to have the gyroscope and also the indicator moving. Okay, as we discussed before, it is through the vacuum, the pump, which allows for the gyroscope to move. And in fact, in an aircraft you wouldn't have someone touching this, okay, but rather it would be automatic. This would move as a consequence of the rotation of the aircraft, as we discussed before. And this is simply an electronic device which is similar, but at the same time, as you can see, there's some variations. Okay, but again, the structure is quite simple, and it always follows the same main keys. Right, so this is a heading indicator. Now, the heading indicator is used in order to understand where our aircraft is moving to. Okay, it's a good way of looking. This would be like a picture from above of what angle we are moving. Okay, what the orientation of the aircraft is with respect to the horizontal plane of the aircraft. Okay, now as you can see, this is indicated from north, east, south and west. In most cases this is the case. Okay, you can configure it as you require, as you prefer, but at the same time this is the nomenclature which is used commonly, and so you can just define what orientation you're moving your aircraft to as based from north, east, south and west. Okay, apart from that, again, it works based on a gyroscope, as you can see over here, which has a gimbal. Same thing as always, more or less, and there's not much more than I can say. Also say that the most basic instrument, which is the heading indicator, but in the initial phase, was just working with a simple compass. Okay, you can see that if we are checking on north, east, south and west, we can just use a compass to understand that. Okay, but the idea is that by combining it, usually by combining it with the gyroscope, or mainly using just the gyroscope and adjusting the orientation initially, we can just have the same information. Okay, this is what the heading indicator does. Right, so finally, again, as in the case of the case that we mentioned before, the attitude indicator, my friend also gave me very kindly, he's a kind guy, he gave me this this turn indicator, which is again with a gimbal and the gyroscope over here. As you can see, this part rotates, okay, and this instrument is probably one of the most simple ones. We can just determine the roll, okay, so the tilt with respect to the horizontal axis of the aircraft as seen from, you know, in the front or from the back, okay, and this is the idea. Notice also that we have, in order to coordinate our turn, we can make several indications, such as these two lines, which indicate a 2-minute turn, okay. This is considering that 1 degree can be divided into 60 minutes, right? So a 2-minute turn would be on this line, so this over here, which naturally flows from one side to another by changing the roll position, okay? So if we have it over here, this would be a 2-minute, okay? I believe the maximum are more or less like 3 degrees change of rate. So again, it's just an orientative way of understanding how the aircraft is moving, and also the nomenclature or the way in which we visualize this may change from aircraft to aircraft. Okay.